Yes, we've looked at an atom and we learned uh, that it's made up of three basic particles: electron, proton, and neutron. So let's look deep into these particles, right? And let's fetch some fundamental information that we need to know, right? What is relevant? Let's focus on that, and then and these three fundamental particles are very relevant. So it's necessary to actually look into it and fetch some information from there that will form a foundation of all of them. Remember, this playlist is actually to mm, prepare you, get you to introduce you to chemistry, the very basic things that is necessary for you to have before we begin to tackle the topic by topic. That's what we are trying to do, right? So take your time and follow the series. And remember that our kind of lessons are targeted to students, to all students, those that are in high school or those that have completed but still want to revise the concept, right? We are making this playlist well for them so that everyone, whether you are smart or not, right, you can relate and actually understand the concept, actually make them concept, own the concept. That's our target. So kindly follow in chronological order, and then you'll be able to get the concept as you are building them in each and every new video. Don't miss that. Uh-huh. So last time we look at the basic model of the atom, and this was uh, what we use, and this is what we look at. That the atom is made up of these neutrons, electrons, and we talk about their locations. And yeah, so yeah, basically this is what we had. But there's more to the proton and electron by their name, and then just knowing their name and their location is not enough. There is more to that. So we are going to go um, one step below the layer in order to understand what they actually contain, basically to just fetch some basic information. So the we are going to draw all of them as a ball, right? So basically, so this is a negative, this is positive, and this one does not have anything. So yeah, so this guy is the electron. Electrons, they are negatively charged. The protons, right? They are positively charged. So you can use the P for protons for positive. Electrons are negatively charged. And neutron, these are neutron, like neutral. Something is neutral, neutron. So it doesn't have a charge. It does not have a charge. So the charge is zero. So you don't even write anything. Plus or minus zero. So this guy is neutral. So neutron for neutral, P for proton and positive, and electron takes the negative. So the particles that actually contribute in terms of charge, that contribute charge in an atom, right? They are these two guys. They are the electron and the proton. They are the two guys that contribute um, charges. When it comes to charges, is an electron. Have you heard of electricity before, right? So it's electron city. It's a city of electrons. So that's why we see why it's important to actually understand where they come from, right? So electron city, electricity. So they are the one. This guy is responsible for the flow of electricity that we have. So it's their flow, it's them that is flowing. That's why we call them electricity. But then they work hand in hand with the proton, but they do the major work, and proton also contributes in it. We will look into that, right? Watch our physics series as well, because we'll be making the videos one after the other for you to understand, so that um, we actually own concepts and be able to build a lot of things from the things that we are learning in our schools. Okay. So we are just basically, this is the basic idea, right? We are just basically going to do a look at the table. Yeah, this is the table I'm talking about. So let's basically talk about each of them. So the protons, right? So the particles that are here, we have the particles, protons, electrons, and neutrons. Right? Those are the particles here. So the particles are here. So these are the criteria that we'll be looking at. The various criteria that we have are, we are going to look at the charge. We are going to compare them in terms of mass, compare them in terms of the location. The location, I know we know, but when it comes to charge, right, we are going to talk about relative charge, and the exact charge that they have. The same thing for mass, the relative mass, and then the exact mass. Yeah. So let's talk about the charge first. For proton, the relative charge is positive, right? Positive one. That's why we say it's positive one. Yeah. But the actual charge is in coulomb, right? The actual charge is positive 1.602 times 10 to the power negative 19 coulomb, right? This one, uh, Yeah, if you are doing physics, you will need it in physics in doing some calculation because physics has to do with electricity and stuff, right? So yeah, you have to know this number 1.602 times 10 to the power negative 19 coulomb. The charge of a proton is this. The basic charge of the proton is this. Um, when you come to the mass, right, the relative mass, AMU stands for atomic mass unit. So one atomic mass unit is one unit that is used for atom calculations, right? So the relative one is one AMU, but the exact one, the actual one will be getting to 1.00728 AMU. This is the exact um, mass, and the location is inside the nucleus, basically. If you go to electron, electron is there the opposite of proton. So you see, in terms of charge, right, this one is relative positive one, and this guy is negative one for electron. For the exact charge, they have the same charge. Take note of that. They have the same charge, but just that the polarity or the sign at the end here is what changes. So here is positive, right? But this one is negative, but the same magnitude. 1.602 times 10 to the power negative 19 coulomb. This is the elementary charge. This is the elementary charge E. We'll be using this mostly for electron, right? We'll be using this E mostly in doing a lot of calculations. So you need to know this thing. You have to know this value. 1.602 times 10 to the power negative 19 coulomb. You have to know it. Yes. So this exact charge, relative charge, I know that electron is negative and proton is positive. In terms of mass, relatively, this guy doesn't weigh anything. Like electron doesn't contribute significantly to the mass in an atom, right? And remember, they are on the shell. So yeah. And then look at this. Look at the exact one. If you want to go into exact one, it's 1 over 1840 or 1836 AMU. But if you break that to 0.000543, I look at proton, it's 1.007. So like Python is way, 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 way heavier than um, electron. Electron basically 0 AMU. So they don't contribute much, and they are on the shells outside the nucleus, right? They are outside the nucleus, as we have said. Now let's talk about neutron. Neutron, we said it, no charge. They don't have a charge, so there is no even talk about relative charge or exact charge. If you come to the mass, here is 1 AMU as well, just like proton. Proton, and then what happens? The exact charge is 1.00867 AMU. If you see the proton is 1.00728 AMU. For neutron is 1.00867 AMU. You see that if you compare proton and electron, neutron is heavier, right? Neutron is heavy, is more than the mass of um, neutron is more than that of proton if you compare the two. So this brings the question that the heaviest atomic particle, if you are talking about the atomic particle, the heaviest one is the neutron. The only thing about neutron is that it doesn't have charge. But then when it comes to mass, it's the heaviest atomic particle, followed by what? Proton. Then electron is the last one, right? And then this one too, I didn't write it, it's also inside the nucleus, right? Inside nucleus. Somewhere like that. It's inside the nucleus. Okay. So basically that's what we have. So take note of something. Let's go back to atomic particle. Yeah, so these are atom model. So you see inside the middle here, we have a proton and electron. A proton and neutron in the middle. Proton and neutron are inside the center, and electron are on the shells. And we say electron don't contribute much to any weight or to anything. So what will happen is that if you are going to actually measure the mass of this atom, you have to actually weigh the mass of the nucleus, right? The mass of the nucleus, because the nucleus is where the heavy things are. The neutron is there, and then the proton is there. They are the ones that are heavily contributed to the mass. So we focus on the nucleus when it comes to the mass. So when we were doing the label last time, we gave A here and Z here, and we say A is the atomic mass number. Remember, atomic mass number, because they are the mass number. They contribute heavily to the mass. So that's why we call that part atomic mass number. And then here this is the proton number or atomic number. So the top one is a mass number, and then that one is atomic number. Atomic number refers to the number of protons, and the A refers to the sum of the neutrons and protons inside the nucleus. So neutrons plus the protons, right? That form the A, and they are found inside the nucleus. So, and they are the heavy. They are the one that contribute to the actual mass. So the ones that are out, the electrons are insignificant. Yeah, they have very, very significant mass, so we don't consider them. So is there if you take the nucleus, just weigh the nucleus and then focus on that as the mass of the atom. Yes, so that's why we'll be calling the A the atomic mass number, the mass number of the atom. Yes, that's what we have to know. And then yes, mm, yeah, this is what we have to know about this thing. And further information. Yes, I have one further information for you guys. Um, let's talk about. We have to know this about the atoms, right? Atoms generally. Let's talk about neutral atom. You understand those terms later. Neutral atoms. So atom generally, right? Generally, atoms. If they are neutral, for neutral atom, let's keep this. For the neutral atoms, right? The number of electrons and the number of protons are the same. So the number of electrons is equal to the number of protons. So protons are positively charged and they are inside the nucleus. The electrons are negatively charged and they are outside the nucleus and they are actually around the nucleus, right? Okay. So when you have positive one and negative one, what will happen? When you add positive one, negative one, you get zero, right? So if the entire atom is neutral, meaning that all the positive inside the nucleus and then all the negative outside the nucleus, which is around the shell, which are the electrons, right, are the same. The number of positive and the number of negative, they are the same. When you add them together, the entire thing becomes zero. So those are for neutral atoms. For neutral atoms, again, the number of electrons is equal to the number of protons. We'll get into understanding how ions, right, which is the next basic unit of matter we'll talk about the atoms, right? Now let's talk about the ions in the next session, right? So but then it's going to be based on this particular thing, that in a neutral atom the number of protons is equal to the number of electron. So protons are inside the nucleus and they are positively charged, electrons are on the shells and they are negatively charged. They attract each other electrostatically, right? And then what will happen? Then just neutralize, because positive and negative, we say they have the same magnitude as well. Since they have the same magnitude, but just different polarity, when you add them together and the numbers are the same, then they will just give you zero. That will make the entire atom neutral. Let's look at the next session and see what we can find about and how this thing relate to ions.